In this video, I'm going to explain how to compute cosects using Taylor series approximation, and we'll compare the result obtained from the Taylor series with the built-in function. Okay, for this we are going to implement using C. So I'm going to open Turbo C++. You can also use Visual Studio Code. Open once again. We'll open Turbo C++ 3.2. So you can start the Turbo C++. By default, it will open Turbo C 3 slash bin slash tc folder. So in the editor, you have to type the program. So file, new. If you want to type new file, you can press new. Then it will show no name dot c plus plus or c. I change the default name to C. You can change that one to different C plus plus also. So you need to type the program here. So I open already typed program. So I'm doing cos x now. So first line include hash include stdio.h standard io.header file. Next also include match.header file. Okay, then define pi capital Pi space 3.14. So in your program wherever pi comes, it is be replaced by 3.142. Next void main open bracket close bracket. Okay, then flower bracket open flower bracket int I comma degree. I and degrees are declared as int type, and x some term numerator denominator are declared as floating point type, and sum is initialized to 0. Next printf slash n enter the value in degrees slash n. Here slash n means new line. Again at the end also we used slash n. So slash n is for just to enter the new line, so that the space will be there for each. Since we are going to enter the printf enter the value, no, so we have to enter the values from keyboard. So for that we have to use scanf percentage d comma ampersand degrees. So this ampersand d indicates we are going to enter integer type, and whatever you enter in the keyboard that will be stored in this variable degree. So next we have to convert degrees into radians. So x is already declared as floating point. So x is equal to whatever you enter degree, same variable you have to take into pi divided by 180. So you can declare global variable pi here, or if you want to avoid this line, just write here wherever pi is there, you only type 3.142. Okay, here you define that pi is equal to 3.14. So wherever the capital Pi comes, it is replaced by 3.14. So 180 degree means pi radians. Okay, so for this much degree, how many radians it will calculate. So after that, for sine series, okay, it is numerator is 1 and denominator is also 1 for the very first for the cos series. So I will show you the cos series. You can see here cos x is given by 1 divided by x square by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial plus x to the power of 8 by 8 factorial. What you observe here, first term you can also consider as x to the power of 0 by 0 factorial. Okay, x to the power of 0 is 1. So it is 1 here, first term is 1. Next, this will be incremented by 2. So 2 next to 4, next to 6. So you can observe all are actually even terms. X to the power of 0, x to the power of 2, x to the power of 4, x to the power of 6, x to the power of 6, and sign terms changes alternatively. In the sign, x to the power of 1 by 1 factorial, x to the power of 3 by 3 factorial, x to the power of 5 by 5 factorial, x to the power of 7 by 7 factorial. Here also sign changes alternatively. This you have to keep it in mind. In cos x, first term is 1 because x to the power of 0 is 1, and here x to the power of 1 is 1, so first term is x. So now let us go to the program. Yeah. So if you press Alt Tab, the windows becomes less smaller size. So again, in order to go back to the full screen, press Alt Enter. Press Alt Enter. Click on this. Actually changes to full screen. Okay, it's not changed. So the first term is 1. In the cos series, first term is numerator is 1, denominator is also 1, and I value is initially it is 2. So it is a do while do and while. So do term is equal to numerator by denominator. So numerator num, denominator you can write den or dno. So whatever you declared there, that I'm using. So num is equal to minus num because every alternate term it should change its sign. So that's why minus. Next time it will multiply with minus into minus, it becomes plus. Again plus into minus becomes minus. So minus numerator into x. So it is multiplied by x square. So very first time numerator is 1. So next time it will multiply with minus x square, and sum is equal to sum plus previous term. Okay, sum is 0 initially. So term is numerator by denominator. Very first time it is 1 by 1, and denominator again is equal to denominator into I minus 1. So I value is 2, 2 into 2 minus 1. Okay, so denominator is actually factorial, so to multiply the number with previous value. So every time it will increment this I value, so it will be operated with I into I minus 1. So this do statements, so here it will do. After that it will check the while condition. So while absolute error is greater than equal to absolute value of term is equal to 0.0001, it will repeat. If it is greater, once it fails, then it will stop operation. Next we have to printf cosine of the percentage d. The percentage d is here degree. The cosine of the whatever value you enter, the degree is percentage f. This percentage f is some value it is going to display. The sum is declared as floating point, so that's why percentage f. Degree is declared as int, so you have to write percentage d. So this is the output you're going to get. The cosine of the degree is equal to percentage of the sum is obtained from Taylor series. The sum is obtained from the Taylor series. Okay. Next, we have to print the value of cosine of the degrees using built-in function cos of x. So after that, we have to compare both. And last one is actually after each line semicolon is required. So next, this is the end of the file. So now I have to compile the program. So click on compile, see, it will give no errors are there in this. If any error is there, you have to correct it. If any semicolon is missing or variable name is missing, then you have to correct it. So next, run. You can press Control F9 or Alt R and run. So now I'm entering cos of 0 degree. Now press enter. Now to check the output, you have to go to the window, press Alt W button and go to the output. O, it is capital O, so I press O in the keyboard. So you can see the output. Cos of 0 degrees is 1.000. This is obtained from Taylor series, and cosine of the 0 degree is 1.000. This is from built-in function. So now close this window, Alt W, close C. I will rerun this for different values of this R. So I will enter now 60 degree. Again I will press Alt W, output window W. So see, the enter the value of degree. We entered 60. Cosine of 60 is 0.4999, is approximately zero point 0.5. And cosine of the function 60 degree from the built-in function is also same, 0.49999. So you can approximate this also at zero point 0.5. Cos 60 is off. Okay. Next you can close this window, Alt W, C, and you can also close all the file. Close E, so it will close. Okay, thank you.